Bismillahirrahmanirrahim. Assalamu alaikum bachcho. Welcome to video number 13 of 10th physics. Hopefully you are understanding the lectures very well. In order to study the reflection of sound with the help of an experiment, you have to take two identical pipes. They can be plastic pipes or the pipes made up with the chart paper of suitable length. First we have to arrange the pipes on a table near a wall. Now place a clock near the one end of the pipe and try to hear the sound by placing this pipe on different locations. You have to fix the pipe on the point where you hear the maximum sound. Now measure the angle of incidence. If this is the wall, then this will be the normal. This is the incoming sound, so the angle made by this pipe with this normal will be the angle of incidence. And this is where the sound is getting reflected. Now the angle made by this pipe and the normal will be the angle of reflection. As this is reflection of sound, so the angle of incidence will be equal to angle of reflection. This is the law of reflection. If we slightly lift this pipe to some certain height, the sound that was heard of the clock will disappear. So this is how we study the reflection of sound experimentally. Sound is mechanical wave, so it cannot travel through the vacuum. It needs some medium for traveling. Speed of sound varies with different factors. The first thing that can affect the speed of sound is nature of medium. The speed of sound in liquid is 5 times the speed of sound in gases. So the speed of sound will be faster in liquids as compared to the gases. It will be 5 times more, or it will be 5 times faster as compared to the gases. On the other hand, the speed of sound in solid is 15 times the speed of sound in gases. It means that in solids the sound will travel 15 times faster as compared to the gases. The second thing that affects the speed of sound is the physical conditions. For example, the temperature, the pressure or the atmospheric pressure present at any place. The third thing is humidity. At 21 degrees Celsius and at 1 atmospheric pressure, the speed of sound is 343 meters per second. As soon as the temperature will change, the speed can change, and with the atmospheric pressure change, the speed will change also. With the increase or decrease of humidity, the speed will get affected. The last thing, as sound is wave, so the wave equation V is equal to F lambda can be used to calculate the speed of sound, where V is the speed of sound, F is the frequency of sound, and lambda is the wavelength of sound. The speed of sound can be calculated with the help of echo. First, step number 1. Find one reflecting surface such as wall. The distance between the wall and the person performing the experiment should be 50 meters. First, we have to check or make sure that there is no other reflecting surface other than this one in the surroundings. Then after that, when the person will clap or produce any sound, the sound will come forward towards the wall. In this way it will cover 50 meters, and then after reflection it will go back to the person, so another 50 meters will be traveled. So the total distance covered by the sound will be 100 meters if we hear the clap and its echo. Next thing is, we have to take a stopwatch in order to calculate the time or measure the time. We have to measure the time for the echo of 10 claps. When with the start of the clapping or the first clap, the stopwatch should be turned on and the person should clap 10 times. After this, when the person hears the 10th echo or echo for the 10th time of the clap, the stopwatch must be turned off. The time will be noted for the 10 claps. The average time for one clap can be calculated by T is equal to T10 divided by 10. The time taken for 10 claps divided by the number of claps. Now, according to the basic definition of the speed or velocity, V was equal to S over T, so S is equal to Vt. Now in this particular formula, we will put the value of S to be 100 and time T from here. Then we can easily calculate the speed of sound. Let's start the numericals of unit number 11. 11.1 numerical has two parts. The first one is a normal conversation involves sound intensities of about 3 into 10 raised to the power minus 6 watt per meter square. What is the decibel level for this intensity? Intensity level of sound was given I is equal to 3 into 10 raised to the power minus 6 watt per meter square. Threshold intensity or the lowest audible intensity is 10 power minus 12 watt per meter square. Required thing in this first part is the decibel level of the sound. According to the formula of decibel level equals 10 log I by I naught. Putting the values of I and I naught and then simplifying the fraction, in the next step I will take the log of this given value, that is 6.477. When this will be multiplied by 10, the answer will be 64.77 dB. So the decibel level of the sound having intensity 3 into 10 raised to the power minus 6 watt per meter square is 64.77 dB. The second part starts from what is the intensity of the sound for 100 dB. Intensity level or decibel level is 100 dB. I naught is the constant that you must remember or learn. It is 10 power minus 12 watt per meter square and it is 0 bell. Required is the intensity of the sound. According to the formula, decibel level is equal to 10 log I by I naught. Let us put the given values. The decibel level is 100 and I is unknown and I naught is 10 power minus 12. In the next step, take this 10 to the other side, it will be 100 by 10, and take this 10 power minus 12 from the denominator into numerator, so its power will become positive. Now 100 by 10 is equal to 10 equals log I into 10 power 12. Now we have to take anti-log on both the sides. When we will take anti-log, this will become anti-log 10 and this log will disappear and we will be left only with I into 10 power 12. Now anti-log 10 is 10 raised to the power 10 is equal to I into 10 power 12. Take this 10 raised to the power 12 to the other side, it will become 10 power 10 divided by 10 raised to the power 12 is equal to intensity level I. Now take this number in the numerator, we get 10 power 10 minus 12, that is I is equal to 10 power minus 2 watt per meter square. When we write this value, which is in scientific notation, into usual notation, it will become 0.01 watt per meter square. So the intensity of a sound having a decibel level 100 dB is 0.01 watt per meter square. 11.2 Numerical. If at an Al-Khalib Bazaar, Lahore, intensity level of sound is 80 dB, what will be the intensity of sound there? Numerical. The dB level is given 80 dB, and again you have to write I0. Whether it is given in the question or not, we have to mention it in the data. That is, I0 is 10 power minus 12 watt per meter square. Required is the intensity of this given sound according to the formula. Decibel level is equal to 10 log I by I0. Decibel level is 80 and intensity I is unknown, and I0 is 10 power minus 12. Now take this 10 to the other side. This will become 80 by 10. Over here log will be left, I will be left, and I have taken this 10 power minus 12 into the numerator, so its power has become positive. Now this will be equal to 8 is equal to log I into 10 power 12. We have to shift this log to the other side, so we have to take, when we take this log to the other side, it will become anti-log 8 is equal to I into 10 power 12. Now anti-log 8 is equal to 10 power 8 is equal to I into 10 power 12. Now take this 10 power 12 to the other side. That will become 10 power 8 divided by 10 raised to the power 12 is equal to I. Now take this into the numerator. We get I is equal to 10 power raised to the power 8 minus 12. The answer is I is equal to 10 raised to the power minus 4 watt per meter square. You can finish the numerical over here while putting the units. If you write this value in the number form, not the exponential form, you get I is equal to 0.0001 watt per meter square. 11.3 Numerical is at a particular temperature, the speed of sound in air is 330 meter per second. If the wavelength of a note is 5 centimeter, calculate the frequency of the sound wave. Is this frequency in the audible range of the human ear? Speed of the sound wave is given, V is equal to 330 meter per second. The second thing is given in the numerical is the wavelength of the note, that is 5 centimeters. Centimeter is not SI unit, so we have to convert it into meters. By dividing the value with 100, we get 0.05 meters. Required is the frequency of the note, and we have to decide whether it is in the audible range of human beings or not. We will apply the wave equation. V is equal to F lambda. Put the values. 330 is equal to F into 0.05. We have to take this number on the other side, it will be divided. F is equal to 330 divided by 0.05. Answer, we will get F is equal to 6600 Hertz, or in scientific notation it is 6.6 into 10 raised to power 3 Hertz. Yes, this is in audible range because the human beings can hear from 20 Hertz to 20,000 Hertz frequency. These are easily heard by the human beings, and 6600 is a value between this that comes in this range.